Hello everyone, good afternoon. So we'll start with the session 4 on electrostatic potential and capacitors. Okay, so already nama electric potential and electric field அதோட relation பத்தி தான் நம்ம discuss பண்ணிட்டு இருக்கோம். Okay, if you are having the general relations, right? What are the general relations? The gradient formula minus dou v by dou x into y cap minus dou v by dou y into j cap minus dou v by dou z into k cap. Okay, so is the electric field oda relation with the potential function. So for potential function and we will get the electric field by using the gradient formula. Okay, if we are having electric field function given to us, right, we can find what is the potential difference between 2 points. If you do E dot dr and integrate this from the initial limit to the final limit, minus E dot dr, we will get what is the potential difference between these 2 points, initial point and the final point, minus E bar dot dr bar will give us what? It will give us what is the potential difference between the initial point and the final point. So in the integration limits, we have to take it from the initial limit to final limit. Okay, so this is what is the relation between the electric field function and the potential function. If we look at what is the relation between the electric field and potential in case of a uniform electric field. I told you like at least 4 or 5 times we got questions on this gradient formula based panni we got questions, and also we got sometimes questions based on the relation between electric field and potential in case of the uniform electric field. Okay, so uniform electric field and it will be constant in terms of the magnitude, and the other direction also will be same throughout. Other than a uniform electric field, represent we can represent the uniform electric field by having the parallel lines which are equally spaced. So electric field lines will be given by what? Parallel lines that are equally spaced. Okay, so electric field represent panna porom. So now here you see that we are marking 3 points, point A and point B, point C. If the electric field it is towards the right side. Okay, so the electric field is horizontal. Now when we are moving from point A to point B, point A we are moving up to point B. Okay, so displacement the shifting position will be like this along this direction. Okay, let us say the separation between the point A and point B is L. Okay, electric field is towards the right side, right? So this is the direction of the electric field. Let us say the angle between them theta vechkonga. Okay, now what is the relation we have? We are moving from A to B, right? Minus integral E dot dr, that will give us what is the potential difference between the initial point and the final point. Other relation. Now when we look at the other form, what is the other form? If you move in any direction, this is the integral form. One more form we have, that is the differential form, right? What is that? If you move in any direction, minus delta V by delta R will give us what? Electric field component along that particular direction. So the change in the potential divided by the distance moved along the direction minus value, that will give us what? Electric field component along the direction. Okay, so this is when the change is measurable. Small change in the, what do we say, minus dV by dr, that is equal to what? Electric field along that, electric field component along the direction. Okay, so inga parunga, we are moving from point A to point B, right? So delta V means what? Final point is B, initial point is A, divided by what is the distance, movement distance and L. Electric field is towards the horizontal right side. What is the component of the electric field along that AB line? Paranga, it is making angle theta dana. So what is the component going to be? E cos theta. So that will be equal to what? E cos theta. So idhila enna varum? Minus of, so L nam andha bucket eduthu it will go to the numerator. So minus of VB minus VA means it will be VA minus VB. So VA minus VB order value is equal to what? E into L into cos theta. Okay, va? So that is how we'll have the relation between VA value and VB value. And we can also find what is the relation between, so we have two formulae. One and the integral based formula, the differential or the gradient type formula. So we have used the gradient formula. Now we will look at, say for example, point A and point C. So when a point A and point C, consider point A and point C. Okay, so A and we are moving up to C means what is the distance moved? D. We are moving exactly along the direction of the electric field. So we are moving exactly along the direction of the electric field. So we are moving from point A to point B along the direction of the electric field. Okay, so if minus delta V means what? VC minus VA divided by what is the distance moved D is equal to what? What is the electric field component? So we are moving in the direction of the electric field means on the direction electric field component and the E dana, total electric field value. So ipo parunga D and the bakka minus of VC minus VA means what? That is VA minus VC. VA minus VC ola E into D. So then equation 2 madri vechukonga. Then the equation 1, that is equation 2. If you look at what is so L is dana, this is theta. What is L cos theta means? In this particular right angle triangle, right? Cos theta value another, cos theta will be what? Adjacent by hypotenuse. So L cos theta is nothing but D. So the equation 1 la the L cos theta badala nam enna substitute pannalam D. Appo enna agum? Equation 1 and 2 compare panni parunga. Equation 1 la enna iruka? VA minus VB is equal to E into D. Equation 2 la VA minus VC is equal to E into D. But the two equations la nam enna solla mudiyum? We can say that VB oda value will be equal to VC. Appo neenga and the two expressions pakkathula vechi compare panna, what is the thing you are able to see? First equation, VA minus VB is equal to E into D. That madri second equation enna iruka? VA minus VC is equal to E into D. Compare panna, what we should get? The VB oda value must be equal to what? VC. The value of VB must be equal to what? VC. We can also try to get this relation by another way. So in the equation 1 equation 2 nama compare panna namak the result varum. Apdi illama we can also try to get the same relation VB is equal to VC by using another method. Adana theriyuma. Now we will move from point B to point C. We will move from point B to point C. Okay va? So paranga, if you are moving from point B to point C nichukonga, what happens? We are moving from point B to point C. Okay. So either let us say we are moving a distance x. So what is the formula? Minus delta V by what is the distance moved x is equal to what? Component of the electric field in that BC direction. Electric field is towards the horizontal. BC line epdi vertical. What is the angle between them? 90 degrees, right? What is the component of the electric field along that BC line? It will be 0 dana. Ena electric field is horizontal. What will be the vertical component of that 0? Which means minus delta V and sonanadi VC minus VB by X is equal to 0, which means kandipa VC should be equal to VB. Okay, so idhula irundhu vara conclusion enna theriyuma? If you are having a uniform electric field and we draw a line agatum or surface which is perpendicular to that electric field lines, you draw a line, or even if nama surface draw panla, you can draw surface also which is perpendicular to that electric field lines. Apdi draw panna, then on that line, so idhula BC mattum kadiyadu, nadula we can think about lot of points, D and solala, E and solala, F, G, nariya points nam mark panla. All these points on that line which is vertical or perpendicular to the electric field, and the line irukka ella points oda potentials will be what? Same. Okay, so which means what? The VB value will be equal to VC, which will be equal to VD, which is equal to VE. Apdi, like you draw a line or a surface perpendicular to the field lines. Okay, apdi draw panna, then that particular surface, right, will have potentials will be same at each and every point. Okay, so in the particular aspect patti we are going to discuss about it. We have some special name for that kind of a surface. In the mother number surface draw panna, where all the points on the surface will have same potential, right? Adukku we will give a special name. We will call it as equipotential surface and solo. What do we call it as? Equipotential surface. Okay, but ingenana we need to understand how do we get the relation between the potential difference between 2 points in case the electric field is what? Uniform electric field. Okay, so in the base panni we will just look at one sample question paranga. In a uniform electric field which is 10 Newton per coulomb, direction kuduthirukanga. What is the direction? Towards the right side. Find enna find out pannanom? VA minus VB, adhu madre VB minus VC. நமக்கு என்ன வேணும்? VA minus VB வேணும். Means what? We have to first mark point B and point A. Okay, so point B la irundhu let us say we are moving towards point A. What is the formula we have? Minus delta V by the distance moved, adavadhu 2 meters, is equal to the electric field component in the direction. Ipo parunga, electric field epdi irukka? It is towards the horizontal right side. So this is the electric field direction. Inga irukra angle enna theriyuma? What is this angle? Because the triangle ABC is the equilateral triangle dana, so adanal anga the angle at that corner B will be what? 60 degrees. So what is the component of this electric field in that direction? The BA or direction, what is the component of the electric field? It is E cos theta, means E cos 60. What is cos 60? Half dana, which means the component of the electric field in the direction adanadi E into cos 60, which is E into half. E value namakku irukka, which is 10 Newton per coulomb into half. Idanadi 5. Idu parunga, minus delta V and sonna, it's what? Final minus initial dana. VA minus VB is equal to what? In the 2 and the pakka poidum. So 2 meter into 5 Newton per coulomb. Idana theriyuma? 10 volt SI unit, right? It will be what? 10 volt. Paranga minus, so minus ulla pona it will be what? Minus VA plus VB is equal to 10 volt. But namakku enna venum? VA minus VB we are looking for, right? Means what? Apadi and the rendu pakka nama oru minus edutittu multiply pannalam. Multiply panna enna agum? VA minus VB oda value is equal to what? Minus 10 volt. Paranga, what is the VA minus VB oda value? It will be what? Minus 10 volt. Check pannunga. So what are we doing? B to A and the direction la nama 2 meters distance move panna, the corresponding delta V will be what? VA minus VB. Okay, so what is the formula? The gradient formula dana. In the direction we travel distance 2 meter, means minus delta V by distance covered is equal to what? the electric field or a component in that particular direction. Then the E is towards the horizontal. So component along the BA line will be what? E cos 60 varum. Okay, adulande we are able to find out what is this VA minus VB value. So if it is varum, like if you are having questions on the potential relation in case of uniform electric field, in the madri questions da varum namakku. Okay, so we have to calculate what is VB minus VC value. We have to also calculate VB minus VC. அதுக்கு நம்ம என்ன பண்ணணும்? We should start from B ல இருந்து ஸ்டார்ட் பண்ணிட்டு we should just move அப்படியே we should move towards the C. இங்க பாருங்க, we are moving from B to C, right? Minus delta V by what is the distance? 2 meter is equal to electric field or a component along the direction. பாருங்க, electric field is towards the right side தானா, which means the component of the electric field along the direction will be what? 10. Total value of electric field. Enna? Because it is in the direction only, right? So adhanala the component of the electric field and sonna what is it? We will take the total electric field value. So ipo enadhi 2 and the pakka pona, it will go to the numerator. So minus of delta V means what? VC minus VB is equal to 2 into 10, that is 20 volt. So minus pull it pona, the sign will change, right? It will be VB minus VC. So VB minus VC will be equal to what? 20 volt. Other than namak venum, what they are asking us? VB minus VC value. What is the VB minus VC? 20 volt. Okay. So in the madri questions we have to be also careful about the sign part. For example, if you have a question final examination on that, then what you will be having? Other they will be giving us plus 20 or option irkum, and the madri minus 20 also will be sitting as one of the option. Adhula nama mistake pannakoodadu. Enna when we clearly say VB minus VC and sonna, it will be what? Potential at the point B minus potential at the point C. So sign value order we have to be taking the final answer. Okay. So this is how we will have the electric field and potential, other relation in case of the uniform electric field. Okay. So when we talked about the understanding of the electric field, over region and namak electric field eppadi irukanu solittu we need to get an understanding, means we use the concept of electric field lines. Okay, when electric field lines represent panna adulundu we will be able to know how exactly the electric field is spread in a particular region. Okay, now if you want to understand how the electric field and potential both are existing in a particular region, Tanya, if you want to just look at the electric field or the existence in a particular region, means we will use the field lines. But if you want to understand the existence of both electric field as well as potential, then we will use the concept of equipotential surfaces. We'll use the concept of what? Equipotential surfaces. Yeah, I mean, this is not like a separate concept. We'll have a relation between the equipotential surface and the electric field lines. So paranga, what is this concept of equipotential surface? See, if you have a charge Q, okay, adulundu at a particular distance R, you measure what will be the potential at this point because of the charge KQ by R dana. What will be the potential at that point? It will be KQ by R. Okay, you take any point at the same distance R, the R distance where you mark any point, what will be the potential value at any of these points? Angiyum and value than irukum. So there also we will have the same value, which means point charge length, if you are marking all the points which are at a distance R, adulundu enna create agum. So if you take a point charge, adulundu we are looking at all the points at a distance R. On the geometrical shape path, what is it that we are going to get? We will actually get a spherical shell varum. What is it that we are going to get? We will get a spherical shell. Okay, by the spherical shell at significance enna theriyuma, all the points on the spherical shell have got the same potential. Paranga, all the points on the spherical shell have got the same potential. So this surface, right, is what we will be calling as equipotential surface. Another, you think of a surface. The surface மேல இருக்கிற எல்லா points we should have the potential value to be same. அப்படி இருந்தா then we'll call the surface as what? Equipotential surface ன்னு சொல்லுவோம். Okay. We'll see how that equipotential surface is related to the electric field lines ன்னு சொல்லிட்டு we'll understand it little bit later. But இப்போதைக்கு என்ன the concept of the equipotential surface. Okay. Equipotential surface, we can have not just one surface. இங்க பாருங்க, let us say this is a point which is at a distance r1. So அங்க இருக்கிற potential என்னது? kq by r1. So you will draw spherical shell of radius r1. That is an equipotential surface. Okay. Each and every point on the surface will have the same potential. Each and every point on the surface will have the same potential v1. அந்த மாதிரி நம்ம இங்க ஒரு surface draw பண்ணலாம். The spherical surface with a radius r2. அதுல என்ன தெரியுமா? Each and every point will have the same potential which is equal to kq by r2. அதையும் ஒரு equipotential surface தானா? You draw spherical shell which is having a radius r2. That is also equipotential surface. The potential value on the spherical shell 2 will be different from potential value on the spherical shell 1. அந்த மாதிரி you can draw one more spherical shell. பாருங்க, you can draw a spherical shell of radius r3. So இந்த surface மேல என்ன தெரியுமா? Potential everywhere will be same. அதோட வேல்யூ என்னது? kq by r3. Like that, in a region we can have many equipotential surfaces. Now equipotential surface oda main significance என்ன தெரியுமா? If you are trying to move, நம்ம ஒரு test charge எடுத்துட்டு we are trying to move the test charge along this equipotential surface, அந்த surface மேல நம்ம மூவ் பண்ணா no work will be done on that particular charge. ஏன் நீங்க பாருங்க, if you are moving from ஒரு point A ல இருந்து point B வெச்சுக்கோங்க, then what is the work to be done? Work to be done is equal to what? Q times delta V. Now we are moving from point A to point B, which means what? Q times point A and point B, they have the same potential because they are on the same equipotential surface, right? They are having the same potential, which is equal to what? In this case, both of them are lying on the surface 3. So which means what? Ingu V3 da varum, ingu V3 da varum. So what is the value? 0. So if you are moving a charge on the equipotential surface, then what will be the work to be done? Work to be done will be 0. So no work will be done by the electrostatic force when a test charge is moved along the equipotential surface. Equipotential surface மேல move பண்ணா no work will be done on the particular charge. Because at each and every point potential is same, right? If you want to measure what is the work done, how do you measure the work to be done? Q times delta V, right? So delta V கிடையாது, delta V will be 0 because each and every point has the same potential. On the surface மேல move பண்ணா all the points are having same potential, right? Which means the work done will be equal to what? 0. Now like on the electric field case la நம்ம ஒரு point சொல்லிருக்கோம், the field lines can never intersect. Remember, if you are representing the direction of the electric field, how do you represent the direction of the electric field? It is given by the tangent drawn to the field lines. If you draw a tangent here, means that represents the electric field direction. So if the electric field lines are intersecting, means the point of intersection la we can draw two tangents, which means electric field can have two possible values. Okay, other it's a contradictory statement. Because at a point, right, we'll have only one electric field only, right? We will not have two electric fields. Adanala the field lines can never intersect. Same way, the equipotential surfaces, they can also not intersect. Two equipotential surfaces can never intersect each other. Because each equipotential surface, inge paranga, let us say for example, we are telling that the first surface is equipotential surface of 15 volt. Means on the surface மேல இருக்க எல்லா points la the voltage will be what? 15 volt. Okay. Surface 2 we are saying it is at 10 volt. Surface 3 we are saying it is a 7.5 volt.
Now, when we say two equipotent surfaces are intersecting means what? Because one surface will give us one potential value, right? Another surface will give us another potential value. So if they are intersecting means what? The point of intersection, we have to have two potentials. And surface 1 will have potential, surface 2 will have potential. If they are intersecting means what? That intersection points will have two potential values. Are they feasible? Because a single point in space can only have one potential, right? Space, if you are marking a point, means that point will only have one potential. So the equipotent surface, just like on the field lines case, the equipotent surface also cannot intersect each other. Now we will go to the relation between the equipotential surface and field lines. Okay, so they are very closely related to each other. If we look at an equipotential surface, representations, representation 1, representation 2. So first we look at the case 1. So we are having a equipotent surface of 40 volt, adukappuram 30 volt, adukappuram 20 volt, adukappuram 10 volt. So each of these spherical shells, they are representing a particular value of the voltage. Okay. Now look at this. We are moving by a small distance along the equipotential surface. Equipotential surface along means what? We are moving along the tangential direction. Okay. So if you are moving along the tangential direction along the equipotent surface, the electric field component along the direction means what? The tangential component will be equal to what? Minus dV by dr, negative of small change in the potential divided by the distance moved in that particular direction. Okay, so we are moving along the equipotent surface, means dV value dV will be 0, because when you move along the equipotent surface, change in the potential will be what? 0, which means this will be what? 0. dV value will be what? 0. Means what? If you have an equipotential surface, the electric field component along that surface or tangential, along the surface and tangential component value of the electric field will be 0, which means if you have an equipotent surface, their electric field cannot have any component along that surface or tangential to the surface, which means it only have one component, which will be what? Normal to the surface. The electric field, right? So you look at this particular equipotent surface, because of a point charge, right? The field will be radially outwards. If the charge is a positive charge, field will be radially outwards. The electric field will not have a component along the equipotential surface or tangential to the equipotential surface. Electric field will be what? Always perpendicular to the equipotential surface. That is relation. See, somebody is giving us an equipotential surface like this, some random surface. At this point, they are asking us, show the direction of the electric field. How do you show the direction of the electric field? You just have to draw a tangent. Electric field will be what? Normal line, which will be what? Perpendicular to the tangent. So at each and every point, right, what is the conclusion? The electric field must be perpendicular to the equipotential surface. At any point on the equipotential surface, the electric field will be what? Perpendicular to the equipotential surface. If case 2, it is what? It is a uniform electric field. Case 2 it's a uniform electric field. Okay, now uniform electric field is represented by what? Straight lines which are equally spaced. Now think about the planes or surfaces which will be perpendicular to these field lines. The field lines are like this, right? What is the surface that will be perpendicular to that? So this is surface 1, this is surface 2, this is surface 3. So we are looking at like lines madri, but they are what? Surfaces. So surface 1, all points will have potential 40 volt. Surface 2, all points will have potential 30 volt. surface 3, all points will have potential 20 volt. So remember, when we draw a line or a surface perpendicular to the field lines, then all points on the surface will have the same potential. So what we call this surface is basically equipotential surface. Okay, observe if you look at as we are moving in the direction of the electric field, what is happening to the potential? 40 we are coming to 30, we are coming to 20. This is another result that we are having from the relation between field and potential, right? If you are moving in the direction of the electric field, then electric potential value will keep on decreasing. Electric potential value will keep on. So, our surface it might S4 number drop, it will have a lesser potential. Surface drop, it will have even lesser potential. Okay. So, if you are going in the direction of the electric field, potential value will keep decreasing. Okay. So, this is how we will have the relation between equipotential surface and field lines. If you are having an equipotential surface, field lines will be always what? Perpendicular to the equipotential surface. Why? What is the reason for that? Electric field cannot have a component along that equipotential surface or tangential to the equipotential surface. Veru and the normal component. Okay, so what is the conclusion? If you have the electric field to be represented, how do you represent the electric field? Just to the given surface, draw normal. So whatever the point they are giving us, right? A normal top one that indicates what? The direction of the electric field. Okay, so we can tell the direction of the electric field by using field lines. Every field lines you draw tangent, that will give the direction of the electric field. You can also tell the direction of the electric field by using equipotential surfaces. You have the equipotential surface means at any point draw a normal. The normal will represent what? The direction of the electric field. Okay, so that is the reason why generally people say equipotential surfaces will be useful in understanding how the electric potential is distributed in a space, and also it will help us to understand how the field is distributed. Okay, va? Question paranga. This is the question that has come in the 2017. Okay. The diagrams below show regions of equipotential surfaces. So paranga. 10 volt ka, 20 volt, 30, 40. Inge 10, 20, 30, 40. 10, 20, 30, 40. But in each of these options, right, the shape of the surfaces change. Okay, wow. So in the first case, we will see that surfaces are plane surfaces equidistant. Option B, it is what? Not plane surface. It is having some curvature. Option C, this is plane surface but equidistant. Option D, curvature. A positive charge is moved from A to B in each diagram. So, we are moving a positive charge from point A to point B. Okay. We have to comment on the work done. In all four cases, option A, in all four cases, work done is going to be same. Option B, they are saying minimum work is required to move Q in figure, I think points miside in figure A. Okay. Option C, maximum work is required to move Q in figure B. Option D, maximum work is required to move Q in figure C. These are the four options. So we have to comment on what to be done. So each of these cases, right, first option la paranga, what is the work to be done? We are moving a positive charge value kudukala. Let us say for example the charge is q. Okay, so a la irundhu b move panna, what is the potential at a? 10 volt. Potential at b eval 40 volt, means charge into delta v, which is what? Q into 40 minus 10, then the q into 30. Okay, option b la paranga, we are again moving from point A to point B dana, which means point A potential level 10 volt, point B 40 volt. So q into 40 minus 10 level 30. Option C la paranga, we are moving from point A to point B. Point A la potential energy 10 volt, point B la 40 volt. Q into 40 minus 10, idanadi 30. Option D paranga, we are moving from point A to point B. Point A potential energy 10 volt, point B la 40 volt. Q into delta V, which is what? Q into 40 minus 10. So what is the conclusion we are getting? All cases we are moving from point A to point B, means the potential difference between point A and point B is same, whether it is option A or option B. Option the shape of the equipotential surface is changing, but we are not bothered about the shape of the equipotential surface. We are not bothered about the shape of the equipotential surface. What is required for us? Only the potential difference. So initial point A and final point B reach pandradhukku, what is the potential difference? What is the potential difference? In each of the 4 cases, we are getting the same potential difference, 30 volt. So what is the conclusion? In all the 4 cases, the work done is going to be same. In all the 4 cases, the work done is going to be same. Okay, wow. So there will be no difference in the work done. All the 4 cases, the work done is going to be what? Same. Because we are only looking at what? Q times delta V. Potential difference. Potential difference, initial point. All options initial point is having a potential 10 volt. Final point la 40 volt. So potential difference all options lo ore value da varum. Okay va? So what is it? We are getting it as 30 volt potential difference in all the 4 cases. Another question paranga. What is not true for equipotential surface for uniform electric field? So already nama paathirkom. Uniform electric field means what? How do we represent the field lines? Field lines are represented by parallel lines with equal spacing. This is what is the representation of the field lines. Okay. Now here they are not asking about the field lines. They are asking about what? Equipotential surface. Paranga, what will be the equipotential surfaces? These are surfaces that will be what? Planes, planar surface. Okay, and they will be perpendicular to the electric field. They will be perpendicular to the electric field. Okay, so we have to comment on the equipotential surfaces. Option A equipotential surface is flat. Like we can see all these are what? They are representing the equipotential surfaces with some specific potential values. So option A is correct. We are looking for which of them is not true. All of that. If you are saying that equipotential surface is flat, then definitely option B cannot be a correct statement, right? Option B la, what are they saying? Equipotential surface is spherical. Flat and sonna, that is what? Planar surface. Spherical there will be no chance, right? So equipotential surface will be spherical when we have a positive charge or negative charge, unit charge. The equipotential surfaces because of the single positive charge or single negative charge, right? In that case, the equipotential surfaces will be what? Spherical. This is already. In that case, the equipotential surface will be spherical. In case of the uniform electric field, equipotential surfaces cannot be spherical. They will be what? Planar surfaces or flat surfaces. Okay. So we are able to conclude the answer. And Option B is the one that is not true. Option C, option C, what are they saying? Electric lines are perpendicular to equipotential surface. This is true every time, right? In the case in each and every case, electric field lines will be what? Perpendicular to the equipotential surface. Option D, work done is zero along the surface. This is also true, not only in this case, but in each and every case, right? If you have equipotential surface, we move a charged particle along the equipotential surface, then work done in moving the charged particle will be equal to what? Zero. Okay. So what is the correct answer for this? Option B is the right answer. Okay, ba? Okay. So next, we'll look at the electric potential due to the distributed charges. What is the thing that we discussed? The electric potential due to a point charge, whether it is a positive charge or negative charge. We discussed about electric potential due to the point charge. Okay. We have talked about the relation between the electric field and electric potential. Now we look at what is the electric potential due to the distributed charges. Okay. The distributed charge we have already in case of the electric field due to the distributed charges. We looked at example of a ring. We give a charge on the ring, that is a distributed charge. We will have a charge on the spherical shell, or we have a charge which is given to the solid non-conducting sphere. Okay, all these are what distributed charges. But even before the distributed charge let us discuss about one important arrangement of charge configuration. We talked about this already. Dipole. What is a dipole? Combination of two equal and opposite charges. So we'll see what is the potential that a dipole will create. Okay. So dipole. Dipole we are discussing. We'll always try to look at some specific points with respect to dipole. So we have the dipole. Okay. So there is a negative charge. There is a positive charge. This line, right, from the negative charge towards the positive charge. This is the line that represents the direction of the dipole moment. What is the value of the dipole moment? Charge times the distance between the two charges, Q into TA. Okay. So first we will try to find what is the potential due to a dipole at a point on the equatorial plane. So equatorial plane we look at what is the potential. So equatorial plane and what is it? I think we have already discussed about it. The plane. What is equatorial plane? The plane that bisects the dipole axis and perpendicular to the axis. So verum on the bisect mattum kediyadhu, it will be also what? Perpendicular. So some people also use the word, instead of using the word equatorial plane, what they say? On the perpendicular bisector for the dipole axis. அப்படி சொல்லலாம். Like this line, right? Either you can think of it like a plane madri, or you can just look at it like a line. So you can think of it like a plane, or you can be simply think of like a straight line madri. Okay. So this line can be also sometimes called as what? Perpendicular bisector for the dipole axis. And in one of the past years questions, right, they have used this word equilateral plane and சொல்றதுக்கு பதிலா what is it that they have used? They have used the word at a point on the perpendicular bisector of the axis. Perpendicular bisector of the axis and so another, that is the line which will be on the equilateral plane. Okay, wow. So we are marking a point. The point is at a distance r. So for dipole and sonna, what is it? It's a combination of two equal and opposite edges dana. So paraga, this is a, it's a right angle triangle, right? So what is the distance? There is a point P and which point P and solalama, or we can use the other. Okay, this is the point. Okay, so what is the distance from A to that point? Hypotenuse, root of r square plus a square. What is the distance of the point from the charge plus q? So what is the potential due to the negative charge? And the negative charge will produce a potential, right? What is it? K into minus q by root of a square plus r square. What is the potential due to the positive charge? K into plus q by in distance and the same distance, right? Root of r square plus a square. What is the total potential? Potential because of positive charge. Potential is a scalar, right? அப்படி நம்ம ஆட் பண்ண போறோம். ஆட் பண்ணா பாருங்க, these two are what? Equivalent. Just potential due to the negative charge is minus, potential due to positive charge is what? Positive. Add பண்ண என்ன வரும்? 0. Which means for a dipole, the potential at any point on the equatorial plane, what is it? It is 0. You take any point. So at any point on the equatorial plane, the potential on the plane will be what? 0. Now I have a small question. In the result based panni, can we say that equatorial plane is also an equipotential surface? அப்படி சொல்ல முடியுமா? ஏன்னா we are taking a general point. Equal plane மேல we are taking a general point, which is the distance r from the center of the dipole. What is the potential there? Total potential. The potential because of positive charge and potential because of negative charge, they are adding up to 0 now. Which means conclusion another, you take any point on the equatorial plane, the potential value will be what? 0 only. Which means can we say that equatorial plane is also equipotential surface? We can say that. And now what is the concept of equipotential surface? You take a surface means at each and every point on the surface, potential should be same, right? Here you take any point on the equal plane, potential is same. What is the value of that? 0. So we can make a note of it. What is it? An equatorial plane for a dipole, right, is also an equipotential surface. Equatorial plane is also what? Equipotential surface. Okay, wow. So அடுத்து பாருங்க, axial line. So what is this axial line? If you are having, say for example, this is the minus 2, this is the plus q. Okay, the center. In the bucket. Total length of the dipole is what? These are all standard notations. Length of the dipole level 2a. What is the charge on the dipole q? Okay. So again we'll look at a point on the axial line. First, axial line and so on, the line that will be joining both these charges. That is the axial line. Okay. So axial line mala we are marking a point which is at a distance r from the center. We are marking a point in the bucket. Where we are marking a point? We are marking a point and observe pannanga. We are marking a point on the side closer to the positive charge. We are marking a point on the side closer to the positive charge. What is the distance of this point from the positive charge? this is R minus A. So potential because of positive charge எவ்வளவு தெரியுமா? KQ by R minus A. Now we look at potential because of the negative charge. அது என்ன வரும்? We have to get the distance. இது ஏதானா? So what is the total distance going to be? R plus A. K into minus Q by R plus A. இப்போ total potential சொன்னா என்னது? We have to add both of them, right? Add பண்ணி பாருங்க. KQ by R minus A minus KQ by R plus A. So denominator என்ன வரும்? R minus A into R plus A. அப்படியே KQ. We have R plus A minus of R minus A. KQ. இதில் என்ன தெரியுமா? R cancel ஆயிடும். 2A divided by R square minus A square. Q into 2A means what? P dana. KP by R square minus A square. What is the value? KP by R square minus A square. So we are having a point on the axial line. Axial line மேல ஒரு point mark பண்ணா what is the potential at that particular point? So the value என்ன வருது? KP by R square minus A square. Okay வா? But என்ன தெரியுமா? So here P is what? The dipole moment. So in P and சொன்னா what is it? It is the dipole moment. Okay. Now here the point that we have marked right is taken on the side which is closer to the positive charge. So now at the point we are taking it on the side closer to the positive charge. Okay. So what is it? K க்கு பதிலா நம்ம என்ன எழுதலாம்? 1 by 4 pi epsilon naught. P divided by R square minus A square. Now all the dipole cases, right? Even in the case of the electric field also, we have this wording. What is it called as? Short dipole. Short dipole also the value of R will be much more than A. The distance measured from the center of the dipole will be very high in comparison to the length of the dipole. Okay. Short dipole what is it? We can neglect the value of A square. After neglect panna, what is it that we are going to get? We are going to get the potential at a point on the axial line because of the short dipole. So what is the formula? 1 by 4 pi epsilon naught P by R square. What is it we're getting? 1 by 4 pi epsilon naught P by R square. The assumption that we have taken is what? We took the point on the side closer to the positive charge. Now initially at the point we have taken the point on the side closer to the positive charge. Okay. If you are taking a point on the other side, if your point is closer to the positive charge, right, then positive potential will be higher, negative potential will be lesser. Adanala when you are adding both of them, the total potential is coming as what? Positive. So this is when these two formulae, right? This is for the short dipole. When the location is on the side of positive charge. What is the other possibility? Look at this. We have a minus Q here. We have a plus Q here. We are taking a point at a distance R. Center of the dipole, we are marking a point. In the we are marking it on the other side. What is the distance from minus to R minus A? What is the distance from plus to R plus A? Okay. So potential due to positive charge will be what? KQ by R plus A. Potential due to negative charge will be what? K into minus Q by R minus A. If we add KQ by R plus A minus KQ by R minus A. So KQ common edutha R minus A minus R plus A divided by R square minus A square. So what is it? K இதுல என்னது R cancel ஆயிடும். Q into minus 2A divided by R square minus A square. பாருங்க என்ன வருது? What is that we are getting? 1 by 4 pi epsilon naught. K க்கு பதிலா நம்ம என்ன 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Q into 2A P தான். But minus இருக்கா. Into minus P by R square minus A square. This is general dipole. Okay. Short dipole எடுத்தா what is it? அப்படி நம்ம அந்த A value நம்ம neglect பண்ண போறோம். Short dipole means what? The value of R will be much higher in comparison to A. Neglect பண்ண என்ன வரும்? 1 by 4 pi epsilon naught minus P by R square வரும். This is for what? This is for the short dipole. So இதுல வர conclusion தெரியுமா? Axial line, point on the axial line சொன்னா we will not be able to have one formula. The electric field case தெரியுமா? We have only one formula for point on the axial line. Axial line மேல நம்ம point எடுத்தா we had only one formula for the electric field, whether the point is taken on this side or that side. But இங்க அப்படி கிடையாது. The potential right value will depend upon which side the point is marked, whether the point is marked on the side closer to the positive charge or the point is marked on the side closer to the negative charge. Finally, what is the conclusion we have to say? We have to say if the location of the point, the meta point or location right, is on the side closer to the negative charge. The negative charge side closer on the pocket, what is it? The V value will be what? 1 by 4 pi epsilon naught minus P by R square minus A square. This is general. But what about the short? For a short dipole, what is the value? 1 by 4 pi epsilon naught minus P by R square. So if you take point on the side closer to the positive charge means you will get plus P. Take a point on the other side means we will get minus P. Means what? If you take a point on the side closer to positive charge means total potential is coming positive. If you take a point on the other side means total potential is coming as what? Negative. Okay, va? So this is how we will have the potential due to dipole on the axial line. We will have to look at potential due to dipole at a general point. Okay. So general point at that particular general point, right, we will see what will be the potential that a dipole will create. Adukapram we'll continue with our discussion on the other type of distributed charges. So we are just looking at a combination of two equal and opposite charges, which is a very important combination of charge. Dipole. Adukapram we will go to the real distributed charges like charged ring, and charged spherical shell, charged solid sphere. Like we will go to the real distributed charges. Okay, va? So just make a note of all these formulae. And maximum, if we are getting questions means we will get questions based on the formula itself. So dipole in the maximum, if you look at the past year question papers, right, we are getting questions mostly based upon the formula itself. The formula is clear. Okay, va?